Have you ever wondered how water can move upward through soil, even against gravity? This happens through a process called capillary action. It's one of the key ways plants access water, soils stay moist, and ecosystems function. In this video, we'll explore the science behind capillary action, see how it works in different types of soils, and discover why it's so important for landscapes and the water cycle. Let's dive in. When rain falls, snow melts, or water enters the soil through other processes, it begins a journey through the ground. Not all water stays on the surface. Much of it moves downward, seeping through the soil layers. This movement of water through soil is called percolation. Percolation occurs when water infiltrates the soil and slowly filters down through the spaces between soil particles. As it moves, it carries dissolved nutrients and minerals deeper into the ground, reaching underground layers such as the water table or aquifers. The rate of percolation depends on factors like soil type, texture, and the amount of organic matter present. For example, sandy soils allow water to percolate quickly, while clay soils slow the process because their particles are tightly packed. Understanding percolation is important for many reasons. It affects how plants access water, influences groundwater recharge, and determines the movement of nutrients and pollutants in ecosystems. Without percolation, water would remain on the surface, leading to flooding, erosion, or poor soil hydration. In short, percolation is nature's way of moving water from the surface into the soil, supporting life, recharging aquifers, and maintaining the delicate balance of our ecosystems. Not all water in soil moves downward. Some of it moves upward or sideways against gravity through tiny spaces between soil particles. This movement is called capillary action. Capillary water is crucial for plant survival, especially between rainfall events. It keeps the root zone moist, supports nutrient absorption, and maintains soil microbial activity. In short, capillary action is nature's way of distributing water within the soil, ensuring plants can access moisture even when it's not raining. Capillary action occurs because water molecules are attracted to soil particles, adhesion, and to each other, cohesion. In very small pores called capillaries, these forces pull water upward, allowing it to reach the roots of plants even if the water table is below them. The efficiency of capillary action depends on soil texture. Fine-textured soils like clay have many small pores, so water can rise higher but more slowly. Sandy soils with larger pores allow water to move downward quickly but limit upward capillary rise. Capillary water is held in the thin films around soil particles by surface tension. It moves slowly and is the main source of water for plants, supplying roots with the moisture they need between rainfall events. Hygroscopic water forms an extremely thin layer tightly bound to soil particles by adhesion. This water is generally unavailable to plants because it is held too tightly. Combined water is chemically bound within the soil minerals themselves. Like hygroscopic water, it is not accessible to plants but contributes to the overall water content of the soil. Understanding these forms of water helps explain how soils store, release, and transport moisture, and why plants rely on some water types more than others. You can observe and measure capillary action in soil with a soil sample, a small tube, and a container of water. Here's how it works. Fill a narrow tube, such as a small glass or plastic cylinder, with soil. Place the tube in a container filled with water so that the bottom of the soil column touches the water. Over time, water will move upward through the soil due to capillary action. The tiny pores between soil particles pull water against gravity. Use a ruler to measure how high the water moves in the soil column. You can also note the time it takes for water to reach different heights, which gives an idea of how quickly capillary action occurs in that soil.